Welcome to another Ask Me Anything event. If you're watching this on YouTube, I invite you to join me live next time. We have these every Saturday at 11 a.m. Eastern, and you can join for free by starting your free trial on quantreasoning.com. Anyone care to rephrase this question so that it's more about positions of x and y on the number line? Yeah, so that's the correct rephrasing. But what this question is really asking is, are x and y both on the same side of 0? Because either way, that would get you a yes, right? If they're both on the right side of 0, you'll get a yes. If they're both on the left side of 0, you'll get a yes. If they're not both on the same side of 0, you'd get a no. So we want to rephrase this question to, on the number line, are x and y located on the same side of 0? So I'll show you statement 1 now. If you know how to translate this statement onto a number line, I think it's very easy to evaluate it. And we talked last week about how something minus something is really just describing the distance between them on the number line. I also talk a lot about number line reasoning in a video I did for GMAT Club, which I'll link to in the description below and above me. But basically what this is saying is that if we place x to the right of y on the number line, then the distance between them is more than -2. And that sounds really weird, because how can a distance be negative? So we might want to actually multiply this inequality by -1 so that we're not talking about a negative distance. And I hope you all remember that if we multiply by -1, so it would be -x plus y, we have to flip the direction of the inequality when we multiply by -1. So this is a good reminder, perhaps, to do that. And if I rewrite that again, it'll be y minus x is less than 2. And that means that if you draw a number line and you put y to the right of x, that distance between them has to be less than 2. And it does also mean that y could be to the left of x. Meaning if you go into the negatives, then the positions of x and y would flip. But I'm wondering, does any of you see why this couldn't possibly be sufficient to answer the question that's being asked? Remember what the question was, how we rephrased the question. Why could this not possibly be sufficient? I think you're onto something here. Maybe I would ask the following. Of all of the numbers on the number line, which particular number, which tick mark is most important for us to know in the context of what they're asking? They want to know, are x and y both on the same side of what? 0. Do we have any idea where 0 is located in the context of x and y on this number line? So if you practice a lot of number line reasoning, it becomes extremely obvious that this statement has no chance of being sufficient on its own, because it gives us absolutely no indication about where 0 goes on this number line. We really shouldn't even need pen and paper if we've been doing a lot of number line reasoning. It's just telling us something about how far away from each other x and y are, but it's not giving us any indication about the position of 0, and therefore it can't possibly be sufficient on its own. Now, what do you think about statement 2 here? How would you translate that onto a number line? Again, I would probably want to multiply by -1, but do you see that it's a very similar kind of statement in terms of the type of information that's providing? I want to show you another way to rephrase statement 1. We had for statement 1, y minus x is less than 2. If I add x to both sides, I could also say y is less than x plus 2. You see that? And then I could say, on a number line, here's x, and then 2 units to the right of that is x plus 2. And where's y? Somewhere to the left of that. Right, so that's another way to draw statement 1 on a number line. And maybe you should do that for statement 2, just to practice. I mean, for statement 2, you could just add 2y to both sides. Right? Adding 2y to both sides, I get this. Draw a number line for that. And say, here's 2y. 1, 2, 3, 4, 5, 6. There's 2y minus 6, and x is somewhere to the left of that. And what you would want to ask yourself is, where is 0 on this number line? Because the question wanted to know, are x and y both on the same side of 0 or not? And I have no idea where 0 is. So my hope is that through this conversation, you realize that evaluating a statement like this in the context of what they're asking can be extremely straightforward if you're in the habit of number line reasoning. It does become obvious that neither of these statements on its own has any chance of being sufficient when they're just not giving us any information about the location of 0 on these number lines. And the question is all about the location of 0. I mean, another way to rephrase the question is 0 in between x and y, or isn't it? Right? If it is in between x and y, then the answer is no. And if 0 is not in between x and y, meaning it's on one side of them, then the answer is yes. So this question really is about the position of 0 on the number line. It's about to get a lot more interesting because we're about to combine these statements to determine between C and E. There is an algebraic way to combine inequalities. Let me go through that rather quickly because that's not a reasoning-based approach. Not really. There's a little bit of reasoning there, I suppose. The idea is to say, if I have two inequalities, and I take the bigger side of the first inequality together with the bigger side of the second inequality, that sum will be greater than the sum of the two smaller sides. And I think that makes logical sense. Just to give you an analogy, if I have more shoes than my brother does, and you have more shoes than your brother does, then you and I together have more shoes combined than your brother and my brother together. So the two bigger sides combined will beat the two smaller sides combined. So that's kind of the reasoning behind this rule. And the rule says take the two bigger sides. So in this case, we've got bigger side and bigger side. So I'm looking at the direction of the inequality signs and grabbing the bigger sides. So combining them, that's x minus y minus 6. That's the two bigger sides combined. And those two sides combined should be greater than the combination of the two smaller sides, which in this case is x minus 2y minus 2.
So you're adding the larger sides, right?
So I added the larger sides on the left side, and I added the smaller sides on the right side. And I'm saying here the sum of the big sides must be greater than the sum of the little sides. So this is the algebraic solution. And what I would do next is add 2y to both sides and also subtract x from both sides. So I did two steps to the price of 1 there. Right? I added 2y to both sides and I also subtracted x from both sides. Now I'll add 6 to both sides. And what I get is that y is greater than 4. Now I still haven't come to some kind of conclusion about x, but I can use this inference about y together with either of the statements. I'll just take the first statement because it seems a little bit easier to work with. And I'll do the same trick again. The two bigger sides now would be x minus y plus y. All right, so the two bigger sides are the y from here and the x minus y from statement 1. And then the two smaller sides are 4 minus 2. And then the y's disappear and you end up with x is greater than 2. Now that we know that y is greater than 4 and x is greater than 2, can we answer the original question? The original question was, are x and y both on the same side of 0? And the answer is yes, we can. They are both on the same side of 0. They're both definitely positive. All right, so that would be the algebraic solution. There's a bit of reasoning there, but no number line reasoning. Let's draw these two statements on number lines. So we'll start there. So adding y to both sides for the first one, x is to the right of y minus 2. And adding 2y to the second statement, x is to the left of 2y minus 6. Is that right? This is what the two statements tell us. X is somewhere in between. It's to the right of y minus 2 and to the left of 2y minus 6. Okay. Now, I'm thinking when I look at 2y minus 6, that's double of y minus 3. 2y minus 6 is exactly double of y minus 3. Why did I think about that? I think the reason I thought about it is because here I have just y, and here I have 2y, and I was trying to think of some way to make sense of those two things relative to each other. And so I thought, well, 2y is double of y, and that would mean 2y minus 6 is double of y minus 3. But where is y minus 3 on this number line? Y minus 3 on this number line will be exactly 1 unit to the left of y minus 2. Because it's another 1 less than y minus 2. So now what are we seeing? We've got some point on the number line all the way here on the left. And when we double it, that moves us all the way to the right here. What kind of number moves to the right on the number line when you double it? It must be positive. That's right. Because any negative number would move to the left when you double it. 0 would stay where it is when you double it. So the insight that we just had looking at this number line is that y minus 3 has to be positive. And if y minus 3 is positive, then who else is positive? Y. Because y is 3 units to the right of y minus 3. And who else is positive? X, because it's to the right of all of this. In other words, we just had the insight that 0 is somewhere to the left of all of that stuff, which answers the question definitively. X and y must both be positive. That's right. That's another way to do it, is to ask yourself, where's 2y minus 4? 2y minus 4 would be 2 units to the right of 2y minus 6. So I did it by looking at y minus 3, but instead you could say, well, here's y minus 2, and 2y minus 4 would be all the way over there, meaning y minus 2 has to be positive. Now, an alternative approach we could use to solve this question with number lines is to focus on y and 2y. So I'm going to isolate y from each of these statements. From the first statement, y would be less than x plus 2. And from the second statement, if I isolate 2y, it would be greater than x plus 6. And when you draw these on a number line, you'd say here's x plus 6, here's x plus 2. The distance between them is 4. And we are told that y is somewhere to the left of that, and 2y is somewhere to the right of that. So again, we ask that million-dollar question. What kind of number moves to the right when you double it? Because we can see here that doubling y puts it way to the right of where y is. Y is somewhere to the left of that point, and 2y is somewhere to the right of that point. And we know that only a positive number would move to the right when we double it. So then y must be positive. And it's not just any positive number. I mean, doubling it is moving it at least 4 units to the right. In fact, it's moving it more than 4 units to the right, because y is to the left of that point and 2y is to the right of that other point. So doubling this number moves it more than 4 units to the right. That means that this number is more than 4. So y is more than 4, which means that, remember, x plus 2 is here, so x would be 2 units to the left of that. If y is more than 4, x must be more than 2, because it's 2 units to the left of something that we know is more than 4. So this is another way to get what we got algebraically. Remember, algebraically, our inferences were these, and now we can see those same inferences from the number line. But remember, the big question that we need to ask is, what kind of number would move more than 4 units to the right when we double it? And the answer to that question is the original number must be more than 4. What's the area in square feet of some rectangle? What we're given is the perimeter and the diagonal. But the numbers are big, bulky, not easy to work with. So I think as a first step, when you see a question like this, and by the way, let me also show you the answer choices just so you see we're looking at big numbers here. For me, I think the first step should be scaling down the numbers that we're dealing with by some kind of scale factor. And then as long as you remember to scale back up at the end, you're good. Now there's one thing though that we need to be careful with when we do this. We're scaling down one-dimensional measurements, meaning lengths. We've got a perimeter, that's a one-dimensional thing. We've got a diagonal, that's a one-dimensional thing, it's just lengths. But the question is asking for an area, which is a two-dimensional thing. So whatever the scale factor we use to scale the numbers down, when we scale back up at the end, we have to square the scale factor because we're going from one-dimensional stuff to two-dimensional. So whatever the scale factor we use to scale down at the start, we'll have to square it when we scale back up at the end. And as long as we do that, we'll be fine. And the math is going to be a lot easier for us if we use some kind of scale factor. In other words, we'll solve this in the world of ratios, and then we'll go back to the original numbers. So we have numbers of 560 and 200. I immediately see a common factor there of 20. But let's do it in two steps. Let's first say, but a factor of 10 gives us 56 and 20. And we'll take a 2 out. We get 28 and 10. And we can take another factor of 2 out, and we get 5 and 14. Now I just want to keep track of the factors that I took out. So what was it again? It was a 10, a 2, and a 2. So that's 40. We scaled down by a factor of 40. I'll just write SF for scale factor is 40. And now our perimeter is 14, and our diagonal is 5. Now if you've memorized your Pythagorean triples, the easiest one to remember and the most commonly tested one is 3, 4, 5. And the reason I thought of that is because I have a diagonal of 5. So it just so happens that the diagonal of this rectangle matches one of the hypotenuse measurements in the Pythagorean triples that we're supposed to memorize, specifically 3, 4, 5. Now, just because the hypotenuse is 5 doesn't automatically mean that it's a 3, 4, 5 type triangle. I only know one side. That's not enough, using the Pythagorean theorem to infer the other two sides. However, I'm told that the perimeter is 14. Do sides of 3 and 4 work out for this rectangle? If the sides are 3 and 4, then the perimeter would be 3 and 4 and 3 and 4. That is 14. Huh, what a lucky coincidence. But they absolutely designed that way on purpose. I think this question is designed to reward people who are comfortable scaling down and scaling back up. I really think that's what this question is designed to reward. So now I know that the lengths of the sides of the rectangle are 3 and 4. I'm using quotation marks because this is scaled down. So scaling back up, we're going to have to expand by a factor of 40 squared. Don't forget to square that scale factor. So the answer is going to be 3 times 4 times 40 squared. So I'm getting 12 times 1600. And personally, I think the way I would solve that is I would think of it as 10 plus 2 instead of 12. 10 plus 2 times 1600. So 10 times 1600 is 16,000. And 2 times 1600 is 3200. So adding those together, I get answer choice A. So does everybody notice the 20 minutes here is it just so happens to be the least common multiple of the 4 minutes and the 5 minutes? Did that kind of jump out at you? When I see something like that, I go, it's not a coincidence. It's designed that way on purpose. And I go, well, thank you, GMAT, because that makes my life a lot easier. I mean, for machine M, if it makes this many widgets in 4 minutes, how many would it make in 20 minutes? 5 times as many. That's right. So I would start jotting down some notes here. In 20 minutes, M makes 5x widgets, and N makes how many Y? 4Y, that's right. Because in 5 minutes, it makes Y, so in 20 minutes, it'll make 4 times as many, so 4Y. So I feel like that we're already off to a good start. What this question is really asking is 5x greater than 4y? And it's really important in data sufficiency when you get a bunch of free information. I mean, if you think about it, everything up to the comma, everything up to the word does, is just free info. It's not really the question yet. The question starts at the word does. Everything before that is just free info. And it's really important in data sufficiency when you have a bunch of free info to really take the time to think about how that free info could possibly be useful to rephrase what the question is really asking. So that's just a general tip for data sufficiency when there is free info available. So let's look at these statements now. Let's look at them one by one with the rephrased question of, is 5x greater than 4y? So statement 1 looks promising. Unfortunately, though, it's not about 5x, it's about x. Are we allowed to multiply both sides of an inequality by 5? What happens in statement 1 if we do that, if we expand the inequality by a factor of 5? We could rewrite the decimal as a fraction. So it's x is greater than 4/5 y. And if we expand by a factor of 5, we get exactly what the question was asking us. So is 5x greater than 4y? We get a definitive yes. So statement 1 is sufficient on its own, and we can eliminate BCE. I find statement 2 to be a lot more interesting because my first instinct, let me just write the question again. It was, is 5x greater than 4y? My first instinct when I see this statement is to say, it can't possibly be sufficient. Why do I say that? Because knowing how far apart two things are on the number line, right, this statement is telling us that y is exactly 1 unit to the right of x on the number line. Knowing how far apart two things are on the number line couldn't possibly tell me anything about their ratio, which is really what this question is asking about. It's asking, is 5 times x's distance from 0 more than 4 times y's distance from 0? That's what happens when you're multiplying. And knowing how far apart they are couldn't possibly be sufficient. However, we have to be extra careful here because x and y represent widgets being made in some kind of factory, which means we have two constraints on x and y. They have to be integers, and they have to be positive for the story to make sense. These are not just any two random numbers on the number line. They're positive integers. So knowing that they are positive integers and knowing that y is 1 to the right of x, meaning they're consecutive positive integers and y is bigger than x by 1, does that mean necessarily that multiplying x by 5 would be bigger than multiplying y by 4? And because we have that positive integer constraint, I will test cases. I normally don't test cases. But when you have a limited number of possible cases, then sometimes you have to. And I would say, well, what if they're 1 and 2? If they're 1 and 2, then 5x, so put 1 here and 2 here, 5x is 5. Is that greater than, what's 4 times 2? It's 8. And that gives us a no. Do we also have to show a case that would give us a yes? Normally we would. In order to prove insufficiency, you would have to show that you can get a yes and you can get a no. However, in this case, we've already established that statement 1 is sufficient because it gave a definitive yes. Can you imagine statement 1 giving a definitive yes and statement 2 giving a definitive no? Is that possible in the GMAT? No. The statements are not allowed to lie, therefore they can't contradict. So if statement 1 was sufficient to give a definitive yes, then statement 2 has to at least allow for the possibility of a yes. Otherwise, it's an illegal question or illegal statement. So in this case, I don't actually have to come up with a case that gets me a yes because I know that such a case exists, because statement 1 already was sufficient on its own and gave a definitive yes. So we're done. Statement 2 is not sufficient on its own because it's possible from it to get a no, and therefore the correct answer is A. This was another data sufficiency question from the official practice test. I'll give you a minute to take a look. So it is a bit similar to the previous question in the sense that it's data sufficiency with a bunch of free info. All of that stuff before the word was is free info. So our job, before we even go to the statements, and if you're curious, I'll show you what the statements are. This is what they look like. Before we go to those statements, we should really take our time to rephrase what the question is asking. Okay, and I think it's a good idea just to notice that the statements are talking about seconds. Right? The units of measurement in the statements is seconds. So we'll just make a note of that and then just go do some work on the question itself. So what we need to ask ourselves is, at a given speed, what would determine whether the distance was greater than some amount? Your distance will be greater than a certain amount if what? Exactly, if the time was greater than some amount. So we need to take the time to rephrase this question to be about time. Like, was the time spent greater than some number? What number? Well, that's what we need to figure out. And we'd like it in seconds because we notice that the statements are talking about seconds. Perfect. So what I'll do is I'll say, was the time greater than, here's the distance in meters, and here's the speed. The problem is that the speed is in meters per minute. So this is going to give me a time in minutes. And I'd like to have the time in seconds. So if you know something takes 3 minutes, just as an example, I took 3 minutes. How many seconds is that? You're multiplying by 60. That's right. So I'm going to multiply that fraction by 60 and then put my question mark. So now we've rephrased the question. Instead of asking, was the distance greater than 800 meters, we're asking, was the time greater than 800 divided by 125 times 60? And here is where you can really speed up if you've been practicing prime boxing. I have another video I did about how to practice prime boxing. I'll link to that also in the description below and above me. If you've been practicing prime boxing, it'll be very quick for you to see what are the factors that can be reduced in this expression that we have here. So I'm thinking about taking a 5. First of all, 125 is 5 cubed. 5 times 5 times 5. So if I can find a factor of 5 to take out of the 60 and a factor or 2 factors of 5 to take out of the 800, then the denominator can disappear pretty quickly. So if you practice a lot of prime boxing, you'll know that each of the zeros in the 800 is built out of a 2 and a 5, because 2 times 5 is 10. So I've got a 5 in each of those. And once I remove the 5, I'll just be left with a 2 in each of those zeros. And same goes for this 0 here. Every 0, meaning every factor of 10, is made up of a factor of 2 and a factor of 5. So what I'm left with when the dust settles is I have 8 times 2 times 2 times 6 times 2. So I removed the 3 factors of 5, and these are the remaining factors. So was the time greater than this many seconds? So what is 8 times 2 times, I'm seeing, well, 8 is 2 cubed, and I have another 4 2s. So it's 2 to the 7 times 3. Now if you've memorized your powers of 2, then you know that 2 to the 7 is 128. And if you haven't memorized them, it's not that hard to find. It's 2, 4, 8, 16, 32, 64, 128. So 128 times 3, I would probably think of it as 130 minus 2 times 3. That's 390 minus 6, 384. Was the time spent more than 384 seconds? And if you're doing everything right, then evaluating the statements should take just 5 to 10 seconds. Which means that you have a good minute and 50 to do this work, which I think is fair. I think that's plenty. But again, prime boxing is a really good thing to practice. Was the time greater than 384 seconds? Was a rephrased question. So if we know that it's less than 450, is it more than 384 or isn't it? I don't know. Could be on either side of 384. So statement 1 is not sufficient on its own. On the other hand, statement 2 tells us it's more than 400. So if something is more than 400, can you tell which side of 384 it is? Yeah, if it's more than 400, it must be more than 384. And therefore, the correct answer is B. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.